starting session here. Okay. All right. So you all can see my screen also, right? This presentation file, like modules. Right? Okay. Is it visible, guys? You all can see my screen?
Yeah, we can see.
Okay. All right. So I'm starting same topic, IP addressing. So let me quickly go through like 1 or 2 slides first, and then I'll give you a quick recap review of previous session also. But before that, let me quickly jump to presentation file first. Okay. All right. So yesterday we started with IP address or IP addressing is a numeric identifier assigned to each machine on an IP network or network. It designates the specific location of a device on the network, and an IP address is a software address, not a hardware address. So we discussed in yesterday's session like difference between software and hardware address. And if you guys can remember, then as I said yesterday, like hardware address, also known as MAC address, the acronym of hardware address is MAC or media access control address, or even physical address. So physical address, MAC address, or hardware address, like pre-assigned address, hard-coded, encoded in a chip. So we never assign like hardware address, and hardware address is globally unique. Software address is basically IP address, also known as logical address. So IP address is not hard-coded address assigned by administrator. It's very similar to the house like number or address, in fact, right? So similarly, like here in networking, we have IP address or IP addresses. And then also like I talked about the byte, octet, one of the same thing. A byte is 8 bits, and bit is like these 2 digits, 0 and 1s. 0 and 1s, only 2 bits, and byte is like 8 by 8 bits. Octet is same as the byte, so both are same. So IP address format, the format of the IP address, the like addressing scheme is something like I started write down in this notepad file yesterday. So if I start from like this, what you call it, just like some key points about IP addressing schema. So key point here about IP addressing is, let me take different one. Okay. So there are some key points here. And key points is like IP version 4 address. Version 4 address is represented in decimal format, decimal. And here there are 4 octets separated by dot, the symbol. There are 4 octets, right? So generally, IP address is like some address, then dot, and then again some portion here, then dot, and then address here, like this one. So total there are 4 octets, 8 bits, 8 bits, 8 and 8. So total 32 bits in binary. So that's the way how IP address is written, in fact. So 4 octets separated by dot, and there are like different classes of IP addresses, and I'm going to talk about different classes. Basically, total there are 5 classes, 5 different classes, total 5 classes. So it's a classification, class A, B, C, D, and E. So class A, we use this, class B, and also class C. So there are 3 different classes, and they all are used in IP unicast communication routing. And there is another class here, and that is known as class D address, and it has a special meaning. And for IP multicast communication. And what is multicast, unicast? I'm going to explain that. So hang in there. I'm going to explain all these points. And then the another class is like class E. So class E address is only for research purpose. Research purpose, not for use, not for use. So it's not for use, not for use, common use. So we never use like class E address. So basically in IP address, the address that we assign, like there are 4 octets. So if I just write down any example, so you will understand like how IP is written. So IP address looks like 192.168.1.1 something, right? So here, if you look at the way like how it is written, so there are 4 octets. The first octet here, 192. Then the next octet, 168, the third octet is 1, and then the fourth octet is 1 again. Means total there are 4 octets here in IP address. All right. And there are like, like some like range of values. Like, so here, if there are 4 octet, like first octet, then the second, third, and the fourth, right? 4 octet. So we are not free to use any value in first, second, third, and fourth octet. No, in second, third, and fourth octet, we can use any number from 0 to 255, 255. In second octet, third, and fourth octet. First octet, now again, it depends like on the classification. In class A, there is different range. Class B is different range, and class C different range, right? But why like classification? Why there are different classes here? How do we decide like what like what class of IP we should use in our environment? So a lot of points like need to be discussed here. But before that, before I just talk like get deeper inside classification, let me quickly talk about this unicast, multicast, and there is another term in networking, and that is broadcast. So what is all this? Unicast communication or routing, and then we have multicast communication, and the third one is broadcast communication. So there are 3 terms basically, broadcast communication. Anyone would like to answer? Like would like to explain these three in general. Even just forget about hardcore networking. So, like anyone from the group, like about unicast, multicast, or broadcast, if you just define in one sentence, like what is unicast communication or multicast communication or broadcast communication. I'm just taking a pause of 1 minute. So if you want to answer this, then you can unmute yourself and you can define like these three, like unicast, multicast, and broadcast. No idea, guys?
No idea.
Okay. So in general, unicast is something like one-to-one communication. So in networking also one-to-one communication. One-to-one communication means like if there is one computer here connected to this centralized network device or switch, and the computer here, and the computer here, and the machine, and another computer. Total, there are 5 computers connected to the switch device. Let's say first machine, this computer, 1, wants to communicate with this guy like computer 5. Means like wants to send some data from here, but at the same time, computer 2, 3, 4, right? Like, so not listen those messages, so not see like what computer 1 is sending, what type of data computer 1 is sending or receiving. It's very much like a targeted message, targeted one-to-one communication. Right? I'm sending data to a specific device machine. But in networking, what happens, sometimes like we also use this multicast communication. Multicast is like one to many, but not all. If I say like this computer 1 is sending, let's say computer 1 is sending a message from the terminal from a Windows machine that you all are requested to shut down your computer or something, any message, let's say. So that's not something known as multicast. It's like a broadcast, basically. Broadcasting means like one to all communication, broadcast, right? So however, multicast and broadcast, they both look very similar because yes, like multicast is a kind of broadcast, but only for a group of people. Like as we are like having this Zoom session, so total we all are 6, right? So it's like it's not like I'm speaking and anyone can join this Zoom session and can hear like can listen what I'm teaching here. No, it's just the communication happening within a group only. We total are 6 guys like in this group. If like it's a free or anyone can join, or if I'm just speaking and anyone from anywhere like across the like globe world can like join, can listen what I'm teaching. So that's something different, not to like multicast, in fact, a kind of broadcast, like I'm just doing broadcasting. And the good example of multicast in IP network. So in general, like unicast is one-to-one, multicast is one to many. One to many means like one sender and multiple receivers or many receivers, but not all. One to many, but not all, right? But not all. And when I use the term broadcast, means one to all, communication. And the good example of this multicast communication in terms of networking is like the content that we see over the internet nowadays. Let's say you have a smart TV or you have subscription of Netflix or Amazon Video. So definitely there would be server or content provider appliance of Netflix, maybe in any data center. And since Netflix is a big company, Facebook is a big company, Google is a big company organization. So only what they do, they distribute their servers, content provider devices in different countries, different cities, so that they can provide like the content from nearby server, right? For example, if someone is in, let's say, in West Africa or East Africa or maybe Asia or US East region or West region, so definitely there would be nearby a server, Netflix server, to provide the content from there, like movies and other stuff, series and web series and all that stuff, right? Where they're big companies, because you understand, like if this Netflix server is in maybe in, let's say, in US East region only, somewhere in the US East, right? So Netflix content provider server means the like source is in, let's say, US East region, and I'm sitting here in India. So you understand, like because of the distance, like a lot of distance I need to travel to reach out to this server by using some underground cable, some iron cable, optical fiber cable, right? That goes through the oceans. So I'll have to reach here, and then this will cause latency, and definitely my experience would not be very good, in fact, right? So if I'm just watching any series on my smart TV, so definitely I would not like be very much happy with the performance because of latency, buffering, and a lot of issues. So only what they do, the service providers, they provision like servers in different countries, nearby locations, right? So if I'm here in India, so definitely Netflix would have a data center in India also, right? Or Google, yes, right? So if, let's say I have to watch a video on YouTube, and if there is a server, YouTube server, content server in the same city, in the same country, so definitely the content would be delivered from there, right? But the routing communication that happens is one aspect, like where is the source? I mean, like where is the source? Where is the server? Where like all movies and series are like saved on the streaming server. Is one aspect, like the location, right? So for better experience, definitely content provider, they spend a good amount of money, like in preparing infrastructure. They deploy servers in different countries, different region, and at the same time the content is not free for all. Like so there is only one source. Let's say source is here, server is here, and this server has like a good storage attached, and a lot of like movies and series and like serials and everything here. Now data is sending from here, like the server, but it's not like anyone who is connected to internet can freely watch the content, can watch the movie. No, if I have taken the subscription from Netflix, I'm subscribed, another user is subscribed maybe in my society, in my apartment, and the third user is not, doesn't have subscription, the fourth one no subscription, no subscriptions, right? So there is a single provider, content is coming from this server. Even internet is like something public network, anyone can get connected to internet, but only those who have subscription of Netflix would be able to watch the content, right? So there is one sender, and there are many receivers, multiple receivers, not all. So the way how this routing is done, the communication that we configure over the internet, And however, we are not going to talk much about this multicast routing or communication in CCNA. This is generally covered in advanced training series like the CCNP level of stuff, but it's also very much part of your networking multicast, right? Because the way how it is configured is known as multicast. It's not a unicast. And let me give you another good example so that you can easily understand these two, right? So let me take one example to make this point more clear. So here is like Netflix server, right? Maybe in the same country, in the same city. Here is internet. Let us assume there is one subscriber here, receiver, another subscriber, subscriber 2, and then subscriber 3, subscriber 4, subscriber 5, subscriber 6. Maybe in the same country, it's okay. Maybe in the same country or different country, right? Now, they all want to watch a movie, a series, or any content of Netflix. So in this example, total there are 6 receivers, subscribers. They all want to get the data. Now, if we configure unicast routing, this one. So unicast means one-to-one communication. So what will happen? This server, the source is here server, will send one copy of data for one subscriber, right? One copy of data for this subscriber. Another copy of same data maybe. They all want to watch the same movie. Another for subscriber 2, then subscriber 3, subscriber 4, 5, 6. Means 6 different copies of same data. 6 different copies, right? One copy for one subscriber, another copy for another subscriber. And that's what unicast communication is. Unicast, if I use the more technical term, so it is known as unicast routing. So unicast communication or unicast routing is something like one-to-one communication, 1:1, right? But it's not the efficient use of internet bandwidth, right? And it's very basic example I took here, because you understand, like 6 user or 6 subscribers, nothing, right? Now, if the content as a whole, let us assume the content of the data is of maybe 5 total series or movie is 5 GB in size, 5 gigabyte, right? 5 GB. And it's not a big amount nowadays, 5 gig, because nowadays we watch like videos in full HD, QHD, 1024, and like very good pixels and all that. Very happy. Now, if we just configure unicast routing, unicast communication, so you understand what will happen. There are 6 copies, means the same data sent like for 6 users, means 5 GB of data for 6 users, means total 30 gig of data is sent from the server, and the media link internet bandwidth, right? Here is the internet bandwidth. Let me put it black color. This is your internet bandwidth. Unnecessary, this internet bandwidth will get choked. It's inefficient use of internet bandwidth. So you understand, in networking, if I assume there is no concept of multicast routing or communication, only unicast, so you understand, like just watching like so many content nowadays, like YouTube and Netflix, Amazon Prime Video, and a lot of other like content providers are there, wouldn't have been possible, right? It's all possible because of the technique, networking, this multicast communication, right? So what happens? Only one copy of data is sent from here, from the server. Only one copy of data is sent from here. only one copy, right? Maybe only 5 GB of data. No matter how many receivers are there, or subscribers are there, and devices in the middle, like the devices that we use is a network device, a router. We'll understand like router in detail later on. So what they do, routers, let's say from here, there's one link, and here, like on this segment, there are 4 or 3 subscribers, and here, like there is another link, another one. So device itself will create multiple copies of the same data. So as long there is a single path, single packet is routed. And if there are multiple routes, multiple path, maybe my server is in US East region, and this is the only server in the US East region only, and then some user, let us assume, are not in the US East region, maybe in US West region. So the device will create copy, multiple replica. One copy will be routed this way, another this way, right? So multicast routing is also very much used nowadays. It's not like that not used, yes. Multicast routing is used because multicast is something one to many, but not all. So as long there is a single route, single path, a single copy of data is sent, and then if required, then multiple copies are created of the same data, one sent here, another here, then again maybe multiple copies. So this way, even like we are using internet bandwidth in very judicial manner, efficient use of bandwidth, right? With this multicast. Broadcast is something is only meant to be for your LAN network. Over the internet, no. Broadcast is not supported, right? Something like, let's say you have 100 computers connected. It's your small office. There are 100 computers in your office. They are connected with a switch. It's a LAN environment. Remember in first class, we discussed about LAN and WAN. Now you want to flash or pop up some messages, right? Let's just assume you want to say something. Let's say you want to say good morning to all 100 computers. You want to broadcast this message. Yes, that is possible, right? We can use a special address, broadcast address, to make this communication happen. So broadcast is one to all. But what is the limitation? Limitation is this is limited to local area network. You cannot use broadcast over the internet, and even that should not be used also. Because internet, you understand, billion people are connected. It's a public network of networks. So even like that's good. Like broadcast is not supported. Otherwise, what will happen? I'm just sending some packet, and if it is broadcasted, means like anyone who is connected to internet will get that data. It's very unethical, should not happen, and exactly never happen that. So broadcast is very much like in your LAN network, in a single network, not supported across different networks. So in different networks, we have only these two types of communication, unicast and multicast. But in general, total, there are 3 types of communication. So in IP address, for this unicast communication, there are different classes. Total, we have 3 options. We can use either class A address, class B, or class C address for unicast. And there is only one class here for multicast. And class A is not for us, for the research purpose. And initially, TCP/IP was developed by US Defense, Department of Defense, and sometimes we use the term DOD just because of that reason, Department of Defense. Because even if you read about internet history, so internet or network of network was initially meant for like US defense system only, sharing information data, become very popular and visually like converted to this internet like it's long back. So a lot of research work initially was done by US defense, and even like they have given a lot of concepts like about this TCP/IP. So this last class E is like reserved, not meant to be used in network anywhere, right? But where is broadcast address then? Like there are three classes for unicast, class D is for multicast. So I said there is no reserved or dedicated class for this address, right? The last address of any network is reserved and used for this broadcast purpose. So I said there is no specific class for broadcast, right? So if I talk about IP classes, so class ABC for unicast and class D for multicast. Class E is for research purpose, not for use. Now, the next question that comes to our mind is like if in very layman language, let's say if I have four computers only, five computers as we connected yesterday, like with a switch, five computers. And so far we have understood that TCP/IP software or protocol is the default protocol. So whenever Windows operating system, Mac operating system, Linux operating system is installed, TCP/IP is installed automatically. We don't have to install this software separately. It's very much part of the operating system. But configuration, TCP/IP configuration, yes, that is required, need to be done by us, like by the administrator. So now if there are five computers connected with a switch, so what type of address, how I should decide like what class of address I should use, and is there any like a rule here? I mean, like if I assign any address to this machine, let's say 192.168.1.1, so can I assign address like this here to another machine? No. If you do that, then they both will not communicate with each other. As such, you will not get any error message, right? Because if the range is valid, so you will not get any error message. Error message, no, you won't get any error message. So simply if I just let me connect only four computer, I'm connecting 1, 2, 3, and 4. So I'm just connecting four machines with this switch centralized device. Sorry. Okay. And then this machine, the third one, and then last one. So total there are 1, 2, 3, and 4 computers here. So physical connectivity is done. So they all are connected, right? So I have connected like all four devices physically this way. Now let's say not this one. Let me delete this. No. So for deletion, just click here and this delete. Yes, delete it. Gone. Okay. So now here, like there are four computers. Click anywhere. Okay. So 1, 2, 3, 4. So as I mentioned, like TCP/IP software, yes, already there, already installed. Just we will have to assign IP address to all four computers, 1, 2, 3, 4. So if I pick this one, PC1, double click to open this window page. So somewhere it's stuck. Getting stuck, just wait. So, okay, it's open after a long time, so something happened. So this is PC0, this one, PC0, you can see in the diagram. And if I go to configure fast Ethernet, and here I'm assigning address like 192.168.1.1, and just forget about this value. And there is another value here, very important, but we'll talk later on, right? Automatically some value will come up here. Just hit down the tab key. So IP address I have assigned to one of the computer here, 192.168.1.1, right? And close this. And then I'm just opening this machine, another one. And to this computer, again, I'm assigning IP 192.168.1.2 and then tab key from your keyboard. So the moment you hit down tab key from your keyboard, automatically some value will come up here, right? Subnet mask. We'll understand what is subnet mask later on. And then close this window. So what I did, I just assigned some value here, like to this PC, to this PC, and what value I assigned here. Let me assign this machine also, and then I will make this point clear to you. So here this time I'm assigning 1.3 and then 1.4. And here 1.4 fast Ethernet. And then here 172.16.1.4. Okay, now let me write it down with the bold. Okay, so what I did, I assigned 192.168.1.1, 192.168.1.2, and here 172.16.1.3, and to this machine 1.4. So it looks like they all are in the same LAN network, local area network, but with just IP address assignment, what I did, I created two networks basically, right? PC1 and PC2 in one network, they will talk with each other, they will communicate with each other, these two computers, right? And this PC 2 and 3 in the diagram, they are now in different network. They will communicate with each other only. And how it happens, so let me discuss that point also. So from physical connectivity point of view, from physical connectivity, it looks like there is only one network, local area network, a network of 4 computers, but with IP addressing, what I did, I created two networks. One network of 2 computers, another network of 2 computers. And what will happen? These 2 computers will communicate with each other, these 2 with each other, but machine 1, this one, cannot communicate with any computer of another network. No, not possible at all, right? It all happens just with IP address only. So you understand like the power, importance of understanding IP address. And why it happens? So if you look at the addressing scheme, the address, so here it is 172.16, 172.16 here like 192.168.1, 192.168.1, right? So it's just because of the like value in the first octet or maybe in the second octet, the number that I took here, right? So let's understand that. What is that in fact? And what is the range? And we are going to understand only the unicast addresses, unicast communication, but unicast also there are 3 classes. So we need to understand 3 different classes here. Let me quickly jump to the presentation file so that you can understand now. So far we have discussed bit, byte, octet, And here is the network address. So in IP address, whatever IP I write, right? Let's say I just write this address 172.16.1.1, right? So basically this IP address has two major components, right? Two major components. One component is network component, a network ID, a network address, and another one is host ID or host address, right? So this IP address has two components, network and host. And what do I mean by network and host? So as you can see, like on the screen, network address is designation used in routing to send packets to a remote network. So too technical to understand, right? It's very technical, like it looks like was written. This is the designation used in routing. So what is routing? Oh, no problem. I'm just going to make it simple. And then here we have broadcast address also. The address used by applications and hosts to send information to all nodes. So you understand like what is broadcast. And here is the portion like network address and the host address, network part and the host part. So as I mentioned, there are 4 octets separated with dot. There are 2 parts in the IP address, decimal representation, 32 bits. But let's first understand what is network and host. Very, very important, right? Network and host. So let's understand that. Network and host. So network and host means like, let's say, there are 4 or 5 computers, right, connected with the switch. So this logical group of computers is obviously known as network. Network like network of 4 computers and the centralized device here for physical connectivity is switch. So there are 4 computers connected with the switch, and this is a network here. So whenever we assign IP address to end devices, right? So what we do, as I mentioned, like the IP address means, like let's say this is the IP address. So IP address has 2 components. One component represents network as a whole, and another component host. Host means individual ID. It's something like if you are putting up in any apartment in any locality in your region, right? And there are different houses or apartments or flats, right, in that locality. So the address or addressing would be something like house number unique, different house number. But since like all houses are in the same society, in the same apartment, maybe in the same building, in the same locality, so locality name or building name or apartment name would definitely be same, right? But the house number, let's say the number is like 49, maybe this one 50, 51A or B or something, and then the like area locality, right? So the house number definitely should be unique, but the area or maybe the apartment name locality, right, would be same. So in networking also, very much whenever we assign IP address, so like the important point here is, let's say there are 4 computers and we are going to assign IP address to all 4 computers. And if I tell you that like the first octet, this one is the network portion. This ID, the first ID is to represent network as a whole. right? As a whole network, this one. If I say like the first octet, the first value that is 10, let us assume is to represent, to define network portion, network ID, this one, 10 is what? Network identification, network ID, network bits. And other three are what? Host. Host means end device, computer, laptops. So now, whenever you will assign IP to all these four computers, so you will have to ensure the first ID, the first number, right, should be same. You cannot change that. The IP should always start from 10 only. And then what about host portion? The host ID, right? Look at the host ID. So host ID is this one, 111 in this case, right? 3 octet, second, third, and fourth. So host ID should be unique. So let's say you if assign 1.1.1.5 maybe. So here 1.1.1.7, yes, perfect, no issue. 1.1.90 will work. 1.1.70, perfect, no issue. And what is the range? Range is any value between 0 to 255. You cannot go beyond 255. Now, very much they will communicate with each other now. Why? Because they all have same network ID, same group number, right? Same group number. So very much they are going to communicate. 10, 10 here, 10 here, and 10 here. Host ID, yes, host ID should be unique. Even cannot be same. Two houses cannot have same house number, right? In the same locality, no. Yes, two houses in different localities can have same house number, no problem whatsoever. But in the same locality, in the same apartment, in the same building, no. Two different flats, different numbers. Same here in networking. Within the same network, two computers, two end devices can never have same address. So who is going to tell like what is like whether first octet is network or second or third or like what? So there is a rule for that, right? There is a rule for that. And to understand that rule, first you'll have to understand classes here. So as I mentioned, in IP address, there are 4 octets like this: 1, 2, 3, and 4. 4 octet, right? 1, 2, 3, and 4. So IPs, like IP addresses, like have been divided into 5 classes, but as I mentioned, only 3 classes, class A, B, and C, are for unicast communication, right? And it's decided, it's like, let me clear the screen and make it clear, more clear. So now I have moved to this classification portion of IP address. Classification. So class A address, the first class, again there are 4 octet: 1, 2, 3, and 4. Then we have class B addresses. Again there are 4 classes, 4 octet, I'm sorry. And then we have the third one, class C. Again 4 octet here, class C. And only 3 classes, right? For what? For unicast communication. And we are understanding unicast routing or unicast communication. Okay, so there are 4 octet, yes, no matter whether IP address is like of class A, B, or C, yes, there would be 4 octets. And even second, third, and fourth octet, if I talk about the value, so they can have any number between 0 to 255. So you can take any value from 0 to 255, not beyond 255, right? Irrespective of the class, whether it's a class A, class B, or whatever, you can take any value from 0 to 255. 0 to 255. First octet here. First octet differentiate classes basically, right? Because up until like we don't find anything different, like in 3 different classes, second, third, and fourth octet, they can have any number from 0 to 255. But what about the first octet? So first octet in class A, number is decided 1 to 126. Class B 128 to 191, and class C is 192 to 223. Is decided, right? By whom? By the internet authorities. They reserved. So if IP address is from this range 1 to 126, means class A address, 128 to 191, class B, 192 to 223 means class C. And now the next concept here is in class A, the first octet, this is network portion. In class B, initial 2 octets network portion, and in class C, here network portion. Right? So this is what? Network portion, network ID in class A. So let me write down properly. So this is network ID or network portion. And here, this portion complete is what? Network ID. And in class C, network ID. Network ID. So now let me put this in different way. Now, first thing, if I just write down any IP address, right? Let's say I write down here and just be attentive here, like, because I'm explaining very important topic. So I expect you all should be very attentive here. So let's say if I write down any IP like 135.60.240.15 IP address. Now, first thing, what you should understand now is, if I ask, what is the class of this IP address? To which class this IP address belongs to? Means class A, B, or C. So which class? Anyone would like to answer?
Class D. D as a dad.
B or what? B?
No D. Since it is 135.
Yes.
It is and D is not even in here. This class C is 192 and 223, right?
Yes. And
So,
class D is like 224 to 239, the first socket. And
yep.
then
This will be class B, like a boy.
No.
Yes. It's like B, he has a boy. That's correct. Why? Because see here.
Between 128 to 191.
Oh, 35. It is a 35. Yep. It's B as a
Yes. Yeah. So you will have to look at the first octet only, first thing. So whenever it is asked, like, just tell me the class of IP address, whether IP address is from class A, B, C, just focus on its very first octet. What is the value? So first octet here is like 135. So first octet is 135. So 135 definitely like falls in this category. 128 to 191, so it is class B, right? Similarly, if let's say now, if I write down another address, so maybe this 191.250.0 dot maybe 10. Now, what is the class of this IP now?
Same.
It's
Class B.
class B, right? But the moment I just change the first octet, let's say 192,
C.
now it's class C, correct? It's class C address. So first thing in IP addressing is identifying class, right? And how you can identify the class. So you will have to remember the range in class A. First octet, if it has any number from this, forget about the second, third, and fourth octet. We are not bothered with the second, third, and fourth octet as they may contain any value from 0 to 255. Class B is like here any number from 128 to 191, and class C means like 192 to 223. Simple, right? So we don't care about the second, third, and fourth class to identify like IP address classes or classification. So if the first octet, any number from this range means class A, first octet, any number from 128 to 191, class B, class C. Now, the next important point that you should keep in your mind is network portion, network ID. So in class A,
I have a question.
yes, sure.
What about 127?
Okay, that's a good question. And even 0 also, right? 0 also,
Yeah.
where 0 has gone, because yesterday even I said like in computer, we always start counting from 0, right?
0 to 9, yeah.
So 0 is not cannot be seen here. Even 127, yes, like it's not here. So I'm coming to like these two values, 0 and 127. Okay, that's good question. Okay, so in class A, the first octet represent network portion, network ID. In class B, initial 2 octets represent network portion, and in class C, initial 3 octet represent network portion. And when I say network portion or network ID, means if you are going to set up a single network, so the network ID, the network portion should be same. That's something really very important. If I just quickly I come back to this presentation like this topology. So now let me write down IP again here so that you can understand the IP that I assigned. And any guesses like whether why if they will first like whether they all will communicate with each other or not, and if not, then why not, and if yes, then why yes? Any guesses, guys? This is the IP address, right? IP address here is like 192.168.1.1, 192.168.1.2, 172.16.1.3, and 172.16.1.4. IP address that I assigned to 4 computers. So what would be the result? Right.
What was the question again?
Question is whether like these 4 computers will communicate with each other or not. Means whether they all are in the same network, because obviously if they all are in the same network, they would communicate then. So whether they and so they all are completely isolated with each other, or like maybe one computer will communicate with another, and then like
the first 2 will communicate to each other, and then the last 2 will communicate to each other, since they are
and why?
Because they have same network, which is like class B, no, class C.
Okay.
And then 192.168. I think they kind of like similar to the first 2, and then this one 172 and 172. They are, I think they are kind of like similar networking.
Yes, so but not here, only 2, 3 in fact. So yes, what I did, I assigned IP address from class C to initial 2 computers, and how I can identify the class. So looking at the first octet, so first octet is 192, So obviously 192 means like class C, and in class C, initial 3 octets, 3 values defined represent network portion, network ID. They are used for network identification. Now, another machine has like IP address 192.168.1 and then .2. So I'm very much concerned with initial 3 values. So yes, 192.168.1, 192.168.1. If you look at the IP address assigned to the third computer, 172.16.1.3, so first thing, even the class is not same here. The class here is B.
And this one is class B, which is like the network portion is the first two.
First two.
Like, yeah.
But and first 2 octets matching with this one, right? And that is why they will communicate, right? They both will be in the same, and here they both are in the same network. So if like I have to put all 4 computers in a same network, I'll have to ensure that they all should have same network ID. Not only the class, first thing, class should be the same, but not only the class, because if I take another example here, if even I assign IP address 192.168.1.1, it's a class C address. And we so far we have understood that in class C, initial 3 octets up to here represent network address. It's a class C network. If I just go to another computer, I assign IP address 192.168.1.2, class C again, and here 192.168.2.3, then it's a problem, right? Just let me discuss these 3. Class is same. Class C network, yes, very much like all 3 machines are in the same class, class C here. Class is same, but network ID or network portion is not same, right? And look at the network ID now. Network ID here on the second machine is same. What about the third one? The value here is 2. So what will happen? These 2 computers will communicate with each other, and third computer is completely isolated. Will never communicate with these 2 machines. Why? Even in spite of using IP address from the same class is same, IP address is from the same class, but network portion, network ID is different. Different region, different locality, different building. The machine has gone to different locality, different area, not in the same area, right? So my point is, first, class should be same. You should pick IP address from the same class. And second, network portion, network ID should be same, and host ID should be unique. And how we can quickly verify all this, whether they are communicating or not? So if I again open this first machine, I show you the IP address, that the IP that I assigned here initially in the beginning, 192.168.1.1, perfect. Second machine, IP address that I assigned 192.168.1.2, perfect. And then the third one, let me change this to maybe 192.168.2.3, and just hit down tab, otherwise will not take 2.3. So if I try to communicate with computer 2 from computer 1, so I'm just like here on PC 0, and the best way is just go to desktop and then command prompt, and from here just run the command ping. Ping is a network connectivity check command, and it is used for many other reasons also, primarily to verify IP reachability, to verify connectivity between devices. But at the same time, we also use the same command to determine latency, to slowness, how fast a network is or slow a network is. So if you remember, so in the very first session, I just use the command ping. Let's say if I say ping and then any address, netflix.com, for example, right? And it's taking very long time, and even like RTO net request timed out, something very horrible, because request timed out means like I'm not getting proper response from here. Something maybe some issue, or maybe this command can also be blocked by some firewall or something. I tried another one like facebook.com, and I got the response, reply from Facebook server, right? I sent 4 packets, received 4 packet, packet lost 0, connectivity is good, there is no issue. But look at this value, time. So first packet took 21 ms, then 9 millisecond, 7 millisecond, 7 millisecond. It's basically a round trip timer, RTT, round trip timer, right? Packet like sent from my machine, reached to Facebook server, and then response packet came back from the Facebook, right? So how much time it took? Round trip timer, sending packet and then getting response message. And I can see here like it's very good, in fact, because if anything you see here like less than 100 ms, even like you can consider your network, your internet connection is good. It's not by because if you let's say, let me try pinging maybe cisco.com. And now see here like maybe a cisco.com server is not in my nearby my region, maybe probably, right? But at least latency, there is some latency I can see here, like the connectivity from my laptop to cisco.com is not very good, because I can see here 200, more than 200, like 274, means it took very long time. So even this command is sometimes used to calculate or measure latency, round trip time, also to verify IP reachability, and a lot of other work, in fact, a lot of other testing, I mean, right? So very useful command ping, and this is built in your Windows, in your Mac, Linux, routers, other networking devices. It's very much part of the same protocol suite, TCP/IP protocol suite. You don't have to install this command, right? So you can run the command ping anywhere on your laptop or desktop or any machine. Ping and then either the name or the IP address here. So best tool to verify internet reachability. And even it is known as ping is known as like we use the term like this ping command is like packet internet dropper. You don't have to remember the full form, no like need to remember that. Just simply you should know like how to use this command. If you have not used before, then you should know like how to use this ping command. That's it. So let me go back to this machine and like here. Okay. So now I'm going to test reachability to the second machine. Yes, any question, guys?
No, I have never used CLI, I mean command line interface before.
Okay.
You're going to, and you know, are you gonna teach us how to use it and how to navigate, how to read?
Oh yes, I will then explain later on. But for now, you can understand if you want to use from this command from your computer, then just open your command prompt like from your Windows. So you will open this. You can open this command prompt from your computer. So once you open this, then you will get this like page. Just the command is ping, and even if you want to know like all the options, which is so you can take the help, like it's a to take the help is like slash and then question mark. So we'll display all possible options here, and see here like a lot of options, and I'll be using some of the options later on in upcoming classes. So for now, I'm not going to use these options, but you can see here like a whole bunch of like options here with the command. But the simple use is like ping, and then either the IP address. I know like IP address. This is the IP address of one of the router of AT&T. So I can test like reachability to this IP. It's over the internet, right? it is in US. The address is in US and I'm pinging from here. So what I did, I sent 4 packets and I got like a response of all the 4 packets. So first thing with this command, what I can verify, so I can very much verify that I'm able to reach to this server, this machine. So I'm sitting here, I'm in New Delhi, India. This machine is in somewhere like in US. I'm connected with the internet, right? So somewhere like a device here, the IP address, I know the IP address. So what I did, I like executed this command. Basically, 4 packets sent here, 1, 2, 3, 4 by default. And even like I got the response of all the 4 packets, right? And how long? Like it took like 304 ms, 303 ms, 30. So I understand like it took long time because of distance, because of slow internet connection, and maybe some other reasons also. Maybe the destination server is slow, right? Not fast. So there's no like like thumb rule in fact that straight away we can jump to any conclusion. Yes, like one of the reason maybe slow internet, maybe server is very slow, not responding, maybe some other congested network in between somewhere over the internet. Any reason, maybe distance, routing issue. So as long I get I don't see any like packet loss here, everything is in good shape. But whenever I see like packet lost, that is something need to be taken care of. So very basic use case is just ping and then the command syntax. I'm not very much sure about your Mac OS. Like I've never worked on Mac, so I think yes, you'll get a terminal window there. Terminal, yes, and same terminal window, yes, and same like in your Linux also, terminal window.
Terminal.
Okay.
Just
so,
type Rashid, then you will see.
Yeah.
Terminal.
Terminal, yeah.
So here, if I now hit down enter and see here, like from computer 1, what I did, I pinged this machine from PC1, PC2. So since I knew like the IP address of PC2, so what I did, ping and then 192.168.1.2. So ping and then 192.168.1.2, and there is proper reply. And even it's a LAN network. And whenever you ping any address in the LAN network, so yes, like the round trip timer is less than 1 millisecond. It's very good because like it's just local area network, right? Just sending packet this way only. It's not like traveling like thousands of miles. Like packet is not traveling thousands of miles. No like hops in between. So most of the time we see this only. And even if LAN environment, let's say you have a network of 100 computers, and if you try you ping one of the host device in the LAN, and you see here something like 50 ms or something, means your network is not good. Network is slow, literally, because in LAN network, no, we should never see like 50 ms or 100 ms. No, it shows like some issue, some broadcasting optimization would be required then, because in LAN network we always expect time means like round trip time less than 1 millisecond. We always expect this. And if we see here like value like 50, 100 ms is very bad network then, right? Some optimization, misconfiguration definitely would be there. And I will explain later on what we can do then, right? In case if we find a value, something like near about 50 or 100 ms in LAN network. So what then we as a network engineer, what we can do then, how we can optimize that network, I'll explain later on that. But yes, at least we can verify that from computer 1, computer 2, yes, we can like communicate. And what about third computer? And the third machine is 2.3 IP assigned, right? And see here. So now I am just sending again 4 packets to the third computer. This one. So I'm trying to verify reachability between these two end devices. And what I can see now, request timed out, right? What happened? This computer tried to communicate with the third machine. First machine sent total 4 packets, received 0, 100% packet lost. So what happens basically after sending a packet, first packet, sender always waits for acknowledgement, right? For a specific length of time. It waits, right? And the time is known as timeout value. And it's like differ like from operating system to operating system. But what happens after sending first packet, how does this command work? So let's say this computer and the third one, first packet is sent. So just immediately the next packet is never sent. It waits now. If the timeout value is, let's say, 2 ms, suppose. So this computer will wait for 2 milliseconds to be heard from the destination, right? Then it sends next packet. Again, wait. No response, then the third packet. No response, fourth packet. And since no response is received, and that is why the message here that we can see on the screen is request timed out. In short, we use the term RTO in networking. Request timed out is very bad. RTO, request timed out, means the sender waited for its timeout value, like maybe 2 ms, or maybe so on some devices you may find some higher value also is default value, and this can be set, no problem. We can configure all this later on. I'll show you. But RTO means something bad. Something bad means either your IP addressing is not up to the mark, you have assigned address from different network, as we did here. What we did, we assigned IP address 2.3 and sender address is 192.168.1.1. So sender and receiver, source and destination, they both are not in the same network. Physically, yes, they both are connected to the same switch, but logically, they both are not in the same network because network ID, the locality, area number, not same, right? It's just the house number kind of thing, the last portion, the host portion. And that is why they are not communicating. So sender, yes, like sent 4 messages, waited for a specific length of time, didn't get any response. That is why we see RTO in the terminal console, request timed out, right? This is one reason. But every time.
I have a question in here.
Yes, sure.
So, and the message is unsuccessfully sent, and because you said they have 2 different networking portion, right?
Yes.
What about your PC and your internet? I mean, network and my internet and my network, they have a different network, and still the message is successfully and sent in back and forth. What makes it different?
Good question. Okay. So the question here is, let me explain the question first, then I will explain the answer. So question here is like, I'm just sitting here, like forget about the LAN IP, local area network. Let's talk it about the WAN IP or wide area network. So my laptop is here. I'm in India. Let's say my address is something 122.10.15.16 or something. Let us assume connected with the internet. You are in, let's say, in different region in US, and let's say your laptop IP is something different, 202.111, and now we both are connected like via internet. And if I try to ping from here to this machine, let's say if I open terminal window of my computer And if I try to ping 202.1.1.1, means like your IP address is all fixed, yes, right? Not the real one. I just took the example. So what will happen? Yes, I will get a proper response, in fact, if there is no restriction in between. So now the question like he asked is like, how does it happen then? I mean, like if my network ID is different, right here, my network ID is something different, your network ID is different. So how they both are communicating with each other? Because as I mentioned, computers on the LAN segment communicate with each other only if their network portions, network IDs are same, right? So how to make this communication happen? Because over the internet, yes, it all happens because internet, what we understand, network of networks, different networks communicate with each other. Cisco network, Facebook network, Twitter, Instagram, Netflix, right? Google, YouTube, different networks, but they talk to each other. That is true. Even I tried to ping Facebook IP, and very much like even I tried to ping this IP is pinging. My IP is even like here is something. Even my real IP is like 122 or something, starting with 122, right? And I pinged 12, and yes, I got the response. So how did that happen? Different networks. That's where routing comes into picture. That's what we will have to understand in this training program, right? So we will have to bring in here another network device. So this one is what? Your LAN network. So this is, let's say, Facebook network, Google network, one network in one city, right? Similarly, maybe a different network here of different vendor, or maybe a end device. And let me put it this way. So another switch here, another computers connected. So this is company A network, this one is B network, different network address. So how this machine will communicate with this computer then, right? Maybe using internet or something. So what we do, then we put a device here, a gateway device, right? A router, gateway is required then, a router, something. And you can see here, like in the configuration itself, even in this machine, if I just quickly go to fast 0 so here in setting page, yeah, in this virtual environment, you can see here the option is something different, static, and then the default gateway page. And in your physical environment, you find this option at different place. So like if I open my Ethernet, my Wi-Fi adapter. So what we do when we connect with the internet, so we use a gateway address, the third configuration. Like first is like IP address, subnet mask is the next one. Like I will talk about subnet mask later on. And the third one is gateway. So gateway is what? A router. So router facilitates or routes traffic across different networks. So how do different networks communicate? With the help of router. Let me use the shortcut key. With the help of routers. With the help of routers, it happens. So if I just, and let me take this example, my example is here itself, let's say, let me open a paintbrush. So question is good, but in order to make you all understand this properly, I'm taking one example here. So I'm taking example of my network itself. So here I have a router here, a home router, my home router. This is my home router, Wi-Fi router. So this is my home router. So Wi-Fi router, right? And here is my laptop. I'm just change this. This is my laptop. This is my laptop. Okay, and here, this is my laptop. Sorry. Okay. And I'm connected with wireless, right? Wireless networking. So here is wireless networking. Okay. And this router is connected where? With internet. This is internet. So connected with internet. Internet. All right. Okay. So my computer IP address, if I write it down here, so my machine IP address is 192.168.1.171. This is my private IP address, right? And my laptop has a gateway address also, a default gateway, and gateway address is 192.168.1.1. And 1.1 is basically my router IP, home router IP address, right? So whenever I try to communicate any destination over the internet from here, as I did, I try to communicate facebook.com, or maybe even I pinged 12.0.1.28 is AT&T router IP address, right? So what happens? 12.0 IP address is not from the same range. I'm using Class C network. So this is my network portion. I try to communicate with this IP. They both are from even different class, even network portion different, right? So in networking, what happens? When the protocol TCP/IP is what? A protocol, a very intelligent software, right? So this software, this protocol, when it realizes that source and destination, they both are not from the same network, they both are in different network. They both are in different network, not in the same network, right? So this protocol, what it does, it checks the configuration that do I have any device that can facilitate communication between different networks to happen? Means like can do routing. Is there any device which can perform routing, which can route my packet to the different network? So if there is a router, there is a network device, and even your laptop, means like there is proper configuration there. So yes, very much we can communicate with different networks, because what will happen now, this computer will send packet to the router, and rest router will take care of that. Router is device like known for the same purpose, means routing across different networks. So with the help of this network device, we communicate with different networks, right? So why I said here like they all need to be in the same network? Because if again I take you to this diagram, here in this network topology, there is no router, there is no gateway, there is no gateway, there is no router. So very much like they are in the same network, in the same LAN. So if here I assume there is another network, and my objective is to ensure connectivity between both network A and network B, then yes, that is possible. And even we will do in upcoming classes, right? We'll put the router here, we'll configure routing. So with the help of routers, routing, different networks communicate, right? But by default, without a gateway, without a router, by default, no communication between different networks. So here also, if these two computers are in different network, these two in different network, if somehow I put a device here, a gateway, a router, even in the same building, yes, they all will communicate then, but using this device as a gateway. And gateway means entry and exit point of the network. So if here you have one network, here another network, so both networks should have entry and exit point, means a gateway device, a router. So with the help of this gateway device, yes, and if there is physical connectivity, then they will communicate with each other. And I was just showing you the configuration of my laptop here. So as I mentioned, like I'm using Wi-Fi adapter is my real physical machine, and as we discussed yesterday, configuration can be, and in your environment, what you will see, find this one, because most of the devices, like by default, we use like this configuration automatically. Since like uh, I'm using this laptop for training purpose, so I will explain some use cases wherein like this manual configuration required. So what I have done, I have configured everything manually over here. But in your environment, in your case, probably you will find this option enabled, obtain IP automatically. But whether automatically or manually, if there is no gateway, no, if I just get rid of this configuration, I get rid of configuration, I will lose internet connectivity then. If I just remove this and apply, right? I'm not going to do that. But if I remove this and if I hit down OK, my internet has gone now. We will get disconnected with the Zoom session even, right? Because this Zoom session is running because there is internet. And why there is internet? Because of this gateway. I'm not going to hit down OK, because you understand what will happen. We all will get disconnected. So I'm going to cancel this. But it happens because of gateway. Make sense? Like, got your answer of your question that you asked? Like, how do different networks communicate? So how do they communicate? With help of gateway, router. So even if I tell you my IP address, public IP address, and if you launch ping from your computer, so very much you would be able to ping my device. Yes, because you definitely using router there, because you are also connected with internet. I'm using router. I'm also connected with internet. So yes, very much we can talk to each other, no problem, right? Very much we can talk to each other. But the problem here again is like something security. If my computer is here, your laptop, you are in CST zone, I'm in IST zone, in different zone, different countries, different even continent, even in different continent. But since we both are connected to internet, so if I share my IP address or you share your IP address, yeah, even you can enable, if you enable your RDP access, so very much I can access your computer, you can access my computer, but the communication that happens in most of the protocols like that we use is like not very secure. It's very insecure, right? Plain text. So it's very risky. Like anybody who is connected to internet can see like what we are just sharing with each other. That is why later on we'll discuss another topic here, and that is virtual private network. To make that communication secure, because just these two computers are communicating, one is in India, another one is in US. That's not enough nowadays, right? That's not enough that they both are communicating now. We would have to ensure secure communication, not only communication to happen, secure. But for security first, you should understand networking first, right? And that is why, as I mentioned, like I said in the very first class, that CCNA is your first step. Whatever career path you are going to choose, you are going to opt for, CCNA definitely would be your first step, because it teaches you networking. And once you understand the networking, you understand like how these two networks, how these two computers communicate over each other. Then the next part would be what? Providing security. secure communication, not only communication. So with networking, most of the time we just discuss how to configure devices so that different networks communicate, same network communicate, right? That's something your networking is, communication to happen. But now, on top of that, how to secure that communication? That's what security is. And nowadays, security is also very, very required, because if, let's say, is I have a very small network, right? And let's say is my Wi-Fi router, I'm connected with internet, like my maybe my family members have like laptop, mobile phone, IP camera, a smart TV, some other home automation appliances at my home, right? And now, if there is no security in place, there is no proper firewall, and if they are not very much educated, I mean, like if they are not aware like how to securely use internet. So yes, nowadays you must have seen like a lot of phishing email attacks and other attacks, like maybe like a mail, like someone just send email with the subject line that you have on like this, you have been selected in this company, or maybe just click here link to verify, know your customer, or maybe they pretend to be a bank employees or something. A lot of things happen, and if I am not very much aware with it, I just click on the link. So maybe my machine, my laptop will get compromised, right? Or maybe some other attack type. Let's say I'm downloading something from the internet, maybe some free software, or maybe some other free like resources from the internet. So you understand, like nowadays nothing comes free, right? Nothing comes free. Literally, there would be hardly 5 or 7% people, or organizations, or companies like really providing something free. Otherwise, like it's not free, right? So if something is like coming free from internet side, so maybe unknowingly, inadvertently, you are also downloading some, like unwanted program, unwanted software on your laptop, maybe some spyware, adware, malware, Trojan horse, or something, right? And it's running on your computer, is spying like what you are doing, like where you are using your credit card or some other information that can be stolen, like your machine can get compromised. So nowadays, not only like just controlling access between different networks, even for secure internet access, right? For secure internet access, you will have to put a firewall, a security device in place, right? Security device in place. In like 10 years back, like generally we used to have firewalls, security devices to like to control communication, like department A should not communicate with department B, department B should communicate with department C, something like that. We used to have firewalls in place. Nowadays, to provide secure internet access, to prevent network from unauthorized access, from these like phishing attack, spoofing attack, malware, spyware, adware, and some other attacks even, we put firewall, in fact, right? But firewall is a security device. It's a gateway, but it's a security device. But you understand, like if like there is proper communication, there is networking, then only we can think about security. So security or firewall is another gateway. It's another gateway. So different networks means gateway. So let's conclude this discussion. Like so far we have discussed, still not I'm not done with it. Like the still like this topic is something need to be discussed further. But let's conclude first, like what we have learned so far. So we have learned that uh, in a single network, right? In a single network, really, if we want to set up a single network, no router, no gateway, no firewall. So first we will have to understand like the IP address class And there is still a big question, and I will answer that question maybe in the next class, because like I need good amount of time to explain that, because that's another very interesting point. Because if there are three classes, class A, B, and C, and I'm very new to networking. Let's say I've been asked to do the networking. What I did, I connected all four computers with a switch. I've finished doing physical connectivity. Now I'm going to assign IP address to all four computers. I know like there are three classes for Unicast, ABC, network ID, host ID. But the basic question here is, how do I choose class? I mean, like whether I should go with class A address, class B, or class C address. That's another important question, right? And rest assured, I will answer this question also, but I need good amount of time to explain this concept, because it's another question, it's still unanswered. So I will talk separately about this, right? Like how to decide like the class, like from which, like I mean, like whether to use class A, B, or C address. I will answer that. But let us assume, because of any reason, you decided to go with class B address. And to first computer, you assigned IP address 172.30.0.5. No problem. So first machine, yes. Randomly, you decided to go with class B. Random IP you picked up because it's absolutely free. Private IP, the internal IP, LAN IP, you don't have to ask anyone, right? Because you're not using this IP address over the internet. So you don't have to ask anyone. So randomly you pick this IP address and assign to first of the computer. No worries. Now, as we know, class B means, and why it is class B? Because 172 means like class B. As as I said, like you'll have to remember this range. 1 to 126 first octet class A, 128 to 191 class B, 192 to 23 class C, and still these two also, like I'm going to answer like 127 and 0. So first machine you assigned 172.30.0.5. Second computer. Now once you have identified that IP address is from class B, and you know initial two octets define or represent network portion, right? So what precaution you will have to take? And you have been asked to put all computers in a single network, only one network, right? You are not going to design multiple networks because you don't have router here. Only one network. So second computer should strictly have same network portion, right? The third machine 172.30, fourth machine 172.30. So what about the third and fourth octet? Any value from 0 to 255, but not exactly the same. You understand, like two machines can never have same address, else like there will be IP address conflict. So let's say I decided to go with 100.200. Yes, fine. Here maybe 4.5, perfect. 0.9 will work, no issue. Now very much they all will communicate with each other. So first identify the class and then understand the rule. If IP address is from the class A, first octet, network portion, first octet should be same. IP address is from class B, initial two octets, network portion should be same. IP address is from class C, initial three octets, network portion should be same. Right? That's what you will have to remember, and you will get like enough time to recap all the discussion, because it's very, very important. So the next class when we would have like maybe on Monday. So I expect like you guys to like just do your homework. I mean, like just maybe watch this recorded session one more time. If any confusion, maybe you can read from some like internet-based resources, articles, but get prepared with the IP address, right? Because it's really very, very important. And quickly, let me answer like where is 127 and 0. So basically 127 address is again like any address that starts with 127 is, and the first address is 127.0.1 is again reserved, and it is known as localhost or loopback address, or localhost you can say. And why this IP address would have been reserved? Just to ensure like the protocol TCP/IP itself is working properly or not. So for the testing purpose, for diagnostic purpose, you don't want to test the network, just you want to test like this TCP/IP, right? Whether the protocol is working fine or not. So even let's say you have a standalone computer, there is no other computer, there is no connectivity. Just you want to ensure like TCP/IP is working on your machine or not. Let's say you have installed any software here and you want to open that software locally from your browser. So what address you should type there in your browser? 127, or simply you can type localhost, one of the same thing, because this will get resolved to this IP address. So this is reserved because of loopback address. And even if I just say here, let's say, let me show you. If I run the command here, ping 127 and any the first address 001. So basically, packet is will get looped now. Will not be sent anywhere, not like out of my machine. No, this packet 127.0.0.1 is like will get looped. Looped means like locally. I'm pinging my machine itself. I'm here on my laptop. This address is not outside my machine. No, it's local address, loopback address, local host. So if I try to ping this address and if I get response, means like the protocol TCP/IP on my machine is working fine. There is no issue with the software. It's just internal testing. Internal testing, you can understand this way, right? So just for the internal testing, address is reserved. So if I hit down enter key and see here, I got the response. So TCP/IP protocol is working fine. So this 127 is not used to verify the real physical network. No, it's just internal address reserved, right? Just to test the TCP/IP. And this 0 address, like 0, the first address is also reserved, and I will explain this later on. And technically, it's known as any network address, not any specific network address. And we use this addressing scheme in routing. I will explain that later on. Default routing. So this address is also reserved, but we use like when we set up different networks, then we use 000, and 127 is also reserved, right? Loopback address. So these addresses, and there are a lot of other addresses, they all are also reserved, and I will get to like those reserved addresses. I hope it's mentioned somewhere in the slide. I'm not sure. Yeah, here it is. So if you look at this presentation file, you will get this. So here it is. Loopback address and all zeros, even any network address. And there are some other addresses as well. They all are also reserved. I will explain like reserved addresses later on. But in IPs, like yes, there are some reserved addresses, right? Reserved addresses. Even the last address of this network is also reserved. Like if I say 192.168.255, last is 255. This is again like a reserved address, never assigned to any machine. And even if try to assign IP address, so you will get an error message here. So reserved addresses means you cannot use. Can we see this? Can we see this? So let's say I try to assign 255. Yeah, it's given error message. And again, if I try to assign 127, is giving error message. So 127, no, not valid. Reserved. 126, yes, I can use. 0, no. Even 0, 000, no. So some addresses are reserved, right? You cannot use those reserved addresses. So any question, guys, so far? Like if any other question, any one has, then yes, you can ask. Like window is open for Q&A. So if any question, any doubt, still we have not finished yet, right? We'll come again on the same topic, the same slide, IP addressing itself. So not done yet, but I expect like whatever we have discussed so far, at least you should get like those concepts revised very well. Physical address, software address, MAC address, IP version 4, whatever we have discussed in 3 or 4 classes. So I expect you guys to recap like those stuff before joining next class. That would be on Monday, I believe. But if like any question, then yes, you can ask here.
Quick
Still.
question. I got a question. When you
Yeah.
were covering on the different classes of IP addresses, class A, B, C, class D, and class E, you identify one of them IP Unicast, the other one IP Multicast, and then class E as a reserved purpose.
Yes.
And at the end, you were talking about broadcast communication. So where does the broadcast communication goes in between these classes?
So that's a good question. So well, for broadcast address, basically there is no specific class like like in IP. Last IP address of any network is reserved, used for broadcast purpose only. So if like as you can see here, like I tried to ping this IP, the last one, as I said, like the like in class C network also, initial 3 octets, let's say there are 2 computers and I have decided to assign class C address, and let's say, and I want to keep like initial 3 octet as 192.168.1. Here also 192.168.1, 3 octets network address, that's perfect. The 4th octet, so if like the 4th octet here, first address cannot be used. First address means 0, cannot be used, reserved for as a network address. We would use that in routing and other stuff, but cannot be assigned. And the last address of the same network, and the last address means 255, right? Last address is broadcast address. 255 here is what? Broadcast address. So in each network class, the very last IP address is reserved, the very last address. And when I say last address, not necessarily always, like if, see here, if I want to assign class B address, and let's say the address here is 1.1, it's a class B address, initial 2 octet network address. So the last address here would not be like this. No, this is not last address. This is not reserved, can be used, right? And even this is not last address, is used, but this one is the last address. Last address means using 255 at host places, host ID 255. This address is reserved and used for broadcast communication. So if I have a network here, a network of, let's say, 200 computers, right? And now if I want to broadcast a message, I want to send a message to everyone, good morning or something on their screen, or any message I want to send to all 200 computers. So what address I should use? So what address I should use? The last address of the network. So if I'm using class B, this one, so what I will do, I will mention 172.16.255.255. That's it. It's understood now. TCP/IP understand. This is the last address. not any specific address, not assigned to any device, right? Means any packet that is sent or destined to the last address means will be sent multiple copies to multiple devices, means all devices, all. So question is good. Like where is like multicast, as we understand class ABC for unicast, D for multicast, E is not for us for the research purpose. So where is like address for broadcast? So there is no reservation, there is no specific class. Last address of a network is used as a network broadcast address. Network broadcast address for that network, but within this network, this broadcast packet will be within this network. So what if I want to broadcast everywhere? Then use this address 255.255.255.255. Everywhere 255. So it's everywhere, like it's not network specific, it's just broadcast. So basically there is no class designated for broadcast communication. The last address is used for broadcasting, and probably we will get that concept also here on this page. So in binary, but we need to get into the binary. So it's written here in the binary, node address of all ones. So all nodes on the specific network. So when we write down all ones in the host portion, so decimal representation equivalent value in decimal is always 255. So in next class, I will explain like binary to decimal conversion, decimal to binary conversion, because that's again like very important concept. So probably you will understand more. But yes, for broadcast, the last address of the network is used for broadcast purpose, and we compute that, we calculate that. So let's say as engineer, if I have to use somewhere broadcast address, so I will find out the last address of the network, right? And I will tell you the way how you can find out. So and that address would be used as a broadcast address. Make sense?
Yeah, and the way it works is that you would change the host to 255, right?
Mm-hmm. Basically, exactly. So at all host places, if we put 255, that becomes your broadcast address.
Excellent. I got it. Thank you.
Okay. All right. So guys, any other question? Good so far? And I assume you'll do your revision well before joining the next session, next class, because next class would be again very important. And as I said, I will invest good amount of time in this module, IP addressing, right? Hardly there are 10 to 15 slides, but the topic is very, very important. It's backbone, your building block of networking. So you can understand networking or security or cyber security or cloud only if you understand TCP/IP very well. So understanding TCP/IP is really very, very important, because all upcoming sessions like routing, even we'll do that also, we'll create multiple networks, we'll do routing, we'll configure that gateway, everything. But again, the building block is understanding the whole TCP/IP. I mean, not only IP addressing, I started with IP addressing, then I will move to subnet mask, then subnetting. Subnetting is another important thing, gateway concept, right? So still, I believe 3 to 4 classes, even if I just take as a whole, gateway, subnetting, subnet mask. So minimum 2 to 3 more sessions. We need good 5 to 6 hours discussion about this TCP/IP. So we'll do that. So probably next week will be dedicated for TCP/IP only, maybe 2 or 3 sessions. So I'm stopping my recording.